within the work that I've done, collaboration's been really important. I think of multidisciplinary research as sort of being the lifeblood of all of the projects that I do.
So I'd say that interdisciplinarity or multidisciplinarity has changed research, because in the past, you know, research was very, very siloed. Basically, you'd have very specific journals on a specific subject. People would spend their entire career publishing in that one location, and there'd be very limited interaction between disciplines. It's now actually well regarded that you can be an interdisciplinary researcher, and it's no longer kind of seen as a stigma. So I think in the last, you know, possibly decade or so, that's really changed, and things like the IRCs are really central to that being the case.
I think the idea of having a big IRC project, being obviously having more funding, means that you can kind of tackle bigger problems as well. So if you all individual projects are only funded, I don't think you kind of have that big goal that you're all working towards.
The benefits that I get from my collaborators is that they provide me with realistic needs, realistic requirements, and therefore I can focus on things that really matter rather than things that just make up.
The benefit of working with chemists and biologists and clinicians is that there's so many things that I can learn about their fields, the problems that are of immediate interest to the project, but also on a broader scale learn what other things we can do together in the future. So I can learn things much faster than reading a textbook. I can just ask a question and explore other ambitious ideas. Yeah.
There's kind of a day-to-day collaboration which comes from basically being in an open plan office. So, you know, we have different researchers from different fields basically in the same room. So you walk into the room and there's a guy there who's got a load of electronics on his desk, and then there's someone else who's you know, a machine learning researcher, someone else who's an HTI person, something like that. So, you know, collaboration is actually a day-to-day occurrence. It's there all the time. You almost can't help it, really.
And I've learned and been exposed to new techniques that I'd never heard of or never thought about, and I was able to like kind of integrate this into my work. So yeah, interdisciplinary research has, I guess, helped to broaden my scientific understanding, and hopefully I can use this knowledge to yeah, hopefully make a difference to society and healthcare.
One of the things that we're trying to do is make ultra-sensitive diagnostic tests. So that means using novel nanomaterials. So I work with chemists to exploit the properties of those nanomaterials, and it's great because we wouldn't be able to do that in isolation. So by working together, we create solutions to these really important problems, and it's almost like we're greater than the sum of our parts when we work together.
So what we're doing is, a part of it is imaging and sensing in a human body, in lung, which is the focus of the project. So we initially planned to do imaging in one way. It's called confocal microendoscopy. But early on in the project we realized we could have a quick entry into clinic by adopting a simpler route. And that wouldn't have been possible if I didn't speak to clinicians, especially Kev Dhaliwal. So through him and other clinical research fellows, we could literally simplify the device to the point where it's much more affordable and much quicker to translate. And that's what we've achieved, and now we need to improve on that device and do more clinical studies.
So I work principally in the development of point-of-care diagnostics. So the aim of the work that I do is trying to create simple technologies that are sort of based on simple concepts for doing diagnostics that are also sort of scalable, easily manufacturable, cheap to develop the reagents for, and also simple to use. In order to create a testing technology, it's not a simple system. You have people that are engineering nanoparticles, you have people that are engineering affinity components, And in order to cover all of those technologies, you need to draw from lots of different academic pools. And so, for example, with Eleanor Gray, we've used her expertise in virology, her expertise in sort of basic biochemistry to allow us to generate our affinity components, sort of go through optimizing the best affinity components that we can have, but also mutating those components, expressing those components so that we can then do orthogonal chemistries to modify those affinity reagents. And that then has led to another collaboration with Vijay Chudasama at UCL as well. And so really, in order to generate the technology that we've been working with, we've had to have those partnerships and had to spread out into different disciplines from at least my background and the background of Molly's group.
So one of my sort of side projects that I'm working on at the moment is I'm using lasers and blue light. So I'm working with a couple of the optical physicists, PhD students, and also their postdocs as well. So I'm actually in charge now using lasers, so I've had to collaborate with them and learn about lasers because it's absolutely nothing about beforehand. I think also because I'm working in making a smart probe, I'm really dependent on the chemists as well, so that eventually in 4 years' time, hopefully I'll have my smart probe that'll be made with chemists and I'll do some of the biology and I can take it into hopefully the clinical environment as well. So it's, my project and it wouldn't be possible without collaborating.